Hey guys, welcome to another tutorial video on chapter 7.3.3, the standard model for particle physics. The learning objectives for today is to look at the nature, range, and strength of the fundamental forces, which include strong, weak, forgot an A there, nuclear, and the electromagnetic and gravitational forces. Let's just fix that up here. Nuclear. Okay. Then we have to look at the exchange particles between those fundamental forces. First off, just a little bit of background history here is, just want to add an extra word here, is something called the fermion. So fermions are quarks and leptons. So quarks and leptons altogether form probably the smallest particles that we're able to discover and find. And these guys are together called fermions after an Italian scientist by the name of Enrico Fermi. Yeah, a little bit of extra background information for you guys. Okay, getting into this, we have our first table that we're going to be looking at, which is going to have our, this is organized by the strength, by the way. So we have the strongest forces on top, and we have the weakest forces on the bottom. Okay, that's not to say that gravity can't crush you, but it is weak in comparison to the strong nuclear force. So let's see here. I do also like some of these visuals here. So the strong nuclear force, it's an attractive force, okay? It's going to hold things together, okay? And it's holding things that actually want to push each other apart, okay? So especially things like protons or things with positive charges wanting to push each other away. Strong nuclear forces, you're too weak. I'm going to hold you together. Weak nuclear force is sort of the opposite of a strong nuclear force in some ways, okay? It's responsible for radioactive decay, so it's trying to split things apart. Gravity, again, is a force that just attracts things, okay? So the electromagnetic is sort of this special thing where it can attract and it can repel. Gravity can only attract. Okay. This next table is found in Cognity. I'm sorry, let me just clean this up a little bit. I was playing around a little bit earlier. And what we've got here is we have, the way you read this is you read gravitation acts on particles with mass and energy. Likewise, electromagnetic acts on particles with charges. Weak acts on quarks and leptons. Strong acts on, quarks. Now, let's quickly talk about the exchange particle, and we'll just cover range at the very end, even though they're sort of like, this is learning objective number 2, and this was learning objective number 1, the strength and the range. So in terms of the exchange particles, the exchange particle for gravity is the graviton, which has not been observed yet. Interesting. Electromagnetic charges, the exchange particle for that is the photon. Okay, so what that really means is that things like electrons, when they're interacting with each other, they're sort of firing photons when they're exchanging with each other, when they're having an exchange. Okay, weak nuclear forces. So we've got 3 different particles there. There's a little table in Cognity that's got that. Okay, so there's the Z boson. That's this guy right here, and then this is the W boson. So the W boson has a positive and a negative. Lastly, we have our gluons, and now. With this last little bit here, I just want to maybe magnify this a little bit further. So gluons are holding our quarks together. Okay, so if you remember, a proton has 2 ups and a down. Our neutron has 2 downs and an up, okay? And then there are other particles as well. So when we talk about strong nuclear force, we're talking about gluons holding these quarks together. The meson is also an exchange particle. But what that exchange particle is doing is it's holding, so remember, this is the proton, this is the neutron. So inside of the nucleus of the atom, this is where this other piece sort of comes in, okay? It's not the pion, it's mesons. And so what we've got here is, so let's say we've got helium, right? Helium has 2 protons and 2 neutrons, right? And so the mesons are actually exchange particles. So I drew that a little bit too close. So in between these protons and neutrons for our helium atom, there is an exchange particle between these guys, and that is the meson. Okay, so the mesons hold nucleons together. Hold nucleons together, okay? So there's sort of these 2 different variations of the strong nuclear force, one of them holding nucleons together, which is the mesons, and then the gluons are holding the quarks together. Okay, and so let's maybe talk a little bit, oh, actually, there's one last thing that I haven't talked about, which is the Higgs boson. So I'm just going to fast forward down here. There is a really, really good video, so I'm going to keep this somewhat short and let you guys enjoy the video Higgs boson, boson. So the Higgs boson is a very interesting discovery, okay? Higgs boson essentially is the particle that sort of mediates or is in charge of the quantity mass. Okay, so the Higgs boson is responsible for, let's sort of say, the existence of mass. It's pretty close to it. Or rather, it's how mass comes to be is due to this idea of what we're calling the Higgs boson field, along with the Higgs boson particle. Okay, this is a little bit of extra stuff. Again, it's just a little bit for your enrichment, but there is a question here on that. So the strong nuclear force is mediated by, and so this is quite obvious here. It's the gluon. Okay, it's not the Higgs boson, it's not the electron, not hadrons for sure. So sorry, this is the correct answer. Okay, these are incorrect. Physical property of mass is explained by, and we just talked about this, the existence of mass is related to the Higgs boson. Okay, so that is going to be the Higgs boson field, right? And then lastly, which of the fundamental forces is the weakest? And you'll notice I sort of purposely arranged this in order from strongest to weakest. Therefore, our answer is D, gravity. Okay, guys, thank you for watching. There is a video which I'm going to link up about the Higgs boson particle. Short video, about 3 minutes long. Highly recommend you guys watch it. Real interesting stuff, okay? Check out the questions on Cognitive, which I will be assigning, and we'll see you guys next time.